Hello, Joshita. Good evening. Good evening. Good evening. Good evening, Akshara. Still anyone is in live? Now, today, what we do, just we will recap our lecture. That's it. Okay. Now, from the after the Saturday, good evening, Vishnu. Good evening, my dear. Good evening. Now, today, what I will do, I will just quickly I will recap the summary of the lecture so that it will be very helpful for us tomorrow. Actually, tomorrow we will do the continuation questions. Actually, tomorrow I am thinking you to take the session of 2 hours so that I can cover the atomic structure, classification of periodic table, and the chemical bonding questions. Good evening, Nitya. Clear? Because we are having the chapters exam on chapters of atomic structure, classification of periodic table, and the chemical bonding, right? So tomorrow I will all the questions, classification of periodic table, chemical bonding, as well as which one and which one next one we are going to see the atomic structure. Today, better what I will do, I will just quickly I will recap this lecture very fastly, and tomorrow we will focus on the lecture. Okay, I mean after the Saturday, from the Saturday onwards, properly we will focus on the lecture one by one. Right? Okay, my dear friends, what I will do when I was asking the question, you know, right? If you know the answer, try to give me the answer very fastly. If you don't know, just give me the question mark. Okay. Good evening, Subhana. Good evening. Right. Now I'm going to start the lecture. Now we'll see. Right. Now, here the chapter called the which one? Chemical bonding. Clear? Now the chemical bonding. Now, what is the meaning of the chemical bonding? Here, how many types of the bonds? This in our chemistry, how many types of the bonds that molecules will form our when we are going to start the organic chemistry. Clear? Now, what is the meaning of the chemicals of the bonds? Now, in our types of the bonds, the first one we are having ionic bond. First one, the bonds we are having ionic bond. Second one, we are having the covalent bond. Right? Now, third, we are having the metallic bond. Right? Now, the fourth, we are having the van der Waals bond. Okay. Now, the fifth, we are having the hydrogen bonding. And the sixth, we are having the coordinate covalent bond. Coordinate covalent bond, or dative bond, we used to say, or dative bond. Right? Now, these are the bonds we are having in our chemical bonding, and the one by one we are going to study. The first will go with the ionic bond, then after that covalent bond, and followed by the metallic van der Waals, hydrogen, and the coordinate covalent bond and the dative bond. Clear? Right. Now, first we are going to study about the ionic bond. First, we are going to study about the ionic bond. My dear friends, this class is just like the summary only for our quick revision. Okay. Now, what are the favorable conditions for the formation of ionic bond? Are electrovalent bond. Ionic bond and the electrovalent bond both are same. Don't get confused. Now, what are the favorable conditions to the formation of ionic bond? Can anyone? Can anyone say me what are the favorable conditions for the formation of ionic bond? The one who are in the live, can anyone say me? Now, what are the favorable conditions for the formation of ionic bond? Can anyone who are in the live, can anyone say me? Now, the favorable conditions for the formation of the what ionic bond? First one, we should have the low, low low electronegativity metal, right? And the second one, IE should be less, and high electron affinity non-metal, and the third one should be the high lattice energy. Now this one lattice energy, the term lattice energy may be the nu to u. Now I will explain very clearly what is the meaning of the low ionization, low electronegativity metal and high electron affinity non-metal. Now what are those? Now we'll see. Low electronegativity metal means sodium Na plus. Good evening Romana, good evening. Clear? Now the example, low electronegativity metal is a Na plus and high electron affinity means Cl minus. Both should be in the gaseous form. Right? Now these two combines to form the ionic compound, that is NaCl. Now my dear friends, once again I was saying there is no any such type of the bond that is existing between the Na and the Cl. Ionic bond, there is no any such type of the bond that is holding Na and the Cl. There is no such a type of the bond that it will be hold the Na and Cl. Only due to the force of attraction of the cation and the anion, they are forming the stable bond only due to the force of attraction. Clear? Now, right? Now, what are the favorable conditions for the formation of ionic bond? One is low ionization energy metal. Now, high electron affinity non-metal and high lattice energy. Sir, what is the meaning of the lattice energy? Now, may I know what is the meaning of lattice energy? Now, lattice energy. Now, what is the meaning of the lattice energy means? Now, the energy released when 1 mole of ionic compound, is formed from its constituent ions in a gaseous state. This is a one very important point you have to remember. Clear? Now what is the meaning of the lattice energy? Energy released when the 1 mole of ionic compound is formed from its constituent gaseous ion. Clear? Here now the interionic attraction increases, lattice energy increases. What does it mean? If this Na plus and Cl minus, when they are attracting to give the 1 mole of solid NaCl, when they are in the constituent gaseous form, right? When they are strongly attracting, now the energy released, that released energy we call it as a lattice energy. The released energy we call it as lattice energy. Clear? Now there is no, once again I am saying, there is no any such type of the bond exist between the Na and Cl, only due to the only force of attraction. Here the charges on this, higher the charges on the cation and the anion, the very force of attraction, very strong force of attraction, and they will form the very stable compound. Clear? Now this point you have to remember. Higher the ionic attraction, higher the ionic attraction, higher the ionic attraction, higher is the lattice energy. Higher is the which energy? Lattice energy. Right? Clear? Is this point is clear for everyone? Is this point is clear? No. No. The lattice energy and the enthalpy both are same. The lattice energy and the enthalpy both are same. That delta H is equal to lattice energy. Delta H is equal to lattice energy. Now here when the lattice energy will be high, when the lattice energy will be high, no, higher the attraction, higher is lattice energy. My dear friends, you just remember this one. Now here Na plus and Cl minus, when they are forming the 1 mole of NaCl solid in its constituent gaseous ion, here the energy released, that energy released we call it as a lattice energy, and the energy released is negative. And one point you have to remember. What is the point you have to remember? Heat released is equal to negative. That we call it as a exo or exothermic. Heat absorbed, that it will be equal to the positive, and that we call it as a endo. Clear? This is a one very important point you have to remember. Clear? Now when these two ions are strongly attracting, they are forming the stable one ionic compound due to that energy released. And that released energy we call it as a lattice energy. Now what are the factors that are affecting the lattice energy? My dear friends, now there will be the one, if they want to ask the question, the first question they will stress with the lattice energy only. If you know the answer, try to give me. If you don't know the answer, just you give me the question mark for this lattice energy questions. Now what are the factors that are affecting the lattice energy? Now we'll see. The first one, factors affecting lattice energy. Now what are the factors that are affecting the lattice energy? Now here we know that potential energy is equal to KQ1 Q2 by R. Now what is the meaning of KQ1 Q2 by R? Now Q1 is a charge of cation and Q2 is a charge of anion. When they are separated at the certain distance, now whatever the energy we are getting, that we call it as a potential energy. In the same way, here also cation Na plus and Cl minus, when they are attracting, now energy is releasing, that we know, right? Energy released we call it as a lattice energy. So what are the factors? On which factor the lattice energy is depending? The same like potential energy. Now the lattice energy formula also will be same, because here also ions, cation and anion, here also one cation and the anion. So the lattice energy formula will be K equal to Q1 Q2 by R. Now what is the R here? R is equal to radius of cation plus radius of anion. Radius of cation and the radius of anion. Clear? This is the radius of cation plus radius of anion. Now lattice energy is inversely proportional to the radius of cation. Lattice energy is inversely proportional to which one? Radius of cation. Now my dear friends, can anyone say me among the LiCl and NaCl? Among the LiCl and the NaCl, which one is having the higher lattice energy? Among the NaCl and KCl, first one, can anyone say me which one is having the higher lattice energy? First point, very first point I was explained. Lattice energy is inversely proportional to the radius of cation. Cation only you cross check and say me the answer. In the first one, which one is having the higher lattice energy? In the second one, which is having the higher lattice energy? In the first one, which is having the lattice energy? In the second one, which is having the higher lattice energy? In the first one, which is having the higher lattice energy? The first one, which is having the lattice energy. In the second one, which is having the lattice energy? Can anyone say me in the first one which is having the higher lattice energy? LICL. Good, good. LICL. Good, good. Because we know here the Cl minus and here the Cl minus both are having the same anion size. Now the only change we know Li plus and the Na plus. Down the group Li plus, Na plus and K plus. Down the group size increases. Size increases. Now what happened? Lattice energy decreases. Lattice energy decreases, right? Now in the first one LICL. In the second one, in the second one case we are having the NaCl. Why? Here the K plus and here it is a Na plus. Here also Cl minus, Cl minus. Now higher the size, lesser will be the lattice energy. Higher the size, what will be the lesser will be the lattice energy. Clear? Done? Right. Now, next one. Lattice energy is inversely proportional to the radius of anion. Right, right. Good, 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 everyone. Good. Now, lattice energy is inversely proportional to the radius of anion. Now, if the radius of the anion, if suppose if they are given, right, right. Good, good, everyone. Good. Now, if suppose if they are given NaCl and NaI, right? Now the next one KCl and KBr. Now in the first one which is having the higher lattice energy, in the second one which is having the higher lattice energy. Now I mean in the first one which is having the higher lattice energy, in the second one which is having the higher lattice energy. The first one which is having the higher lattice energy, in the second one which is having the lattice energy. In the first one which is having the higher lattice energy, in the second one which is having the higher lattice energy. Right, right. Now, in the first one, we are having the NaCl. Why? Here the Na plus and here the Na plus both are same. Here the Na plus and the Na plus both are same. Now, the leftover we have to cross check Cl minus and the I minus. Cl minus and the I minus. Now, we know F minus, Cl minus, Br minus and I minus. Down the group, what happens? Atomic size increases, right? Now atomic size of the radius of the anion increases, lattice energy decreases. In the second one we are having KCl. Why? Here the Cl minus and the Br minus, KK get cancelled, right? Now this is about the, now in this manner you have to cross check the which one for the NaCl and NaI, KCl and the KBr. Now next one, lattice energy is directly proportional to the charge of cation. Directly proportional to the charge of the cation, right? Now, directly charge of the cation means if suppose if they have given NaCl, MgCl2 and AlCl3. If suppose in this manner they have given, among those three which is having the higher lattice energy? Among the 1, 2 and 3, which is having the higher lattice energy? Which is having the higher lattice energy? Now which one is having the higher lattice energy? Good everyone. AlCl3. Right. Higher the charge, higher is a lattice energy, right? Higher the charge, higher is a lattice energy. Right. Now, higher the charge, higher is a lattice energy. Now, next one. Now, next one. If suppose LiCl and BeCl2 if they are given, among the 1 and 2, which is having the higher lattice energy? Among the 1 and 2, which is having the higher lattice energy? Among the 1 and 2, which is having the higher lattice energy? Which one is having the higher lattice energy? Among the 1 and 2, which is having the higher lattice energy? LiCl, BeCl2. Yes, BeCl2 is having the higher lattice energy because due to the higher charge. Because of higher charge, it is having the higher lattice energy. Right. Next one. The very interesting one. Lattice energy is directly proportional to the charge of anion. Directly proportional to the charge of anion. If lattice energy is directly proportional to the charge of the anion means, now Al2O3 and Al2O3 and Al. Now, which one is having the highest lattice energy? 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 Aluminium trioxide and aluminium nitride. Here whenever this type of the compound they have given, already I explained very clearly, right? Now AXBY type. Now these are in that form of the AXBY type. Now this AXBY type will be dissociated. How? X A power Y plus and Y B power X minus. Now you just dissociate in this form. No. ALN is having the higher lattice energy, my dear. Now David physics. Now here the ALN is having the higher lattice energy than the Al2O3. Now this type of the compounds will be dissociated, right? Now the Al2O3 will be dissociated into Al plus 3 plus 3O2 minus. But aluminium nitride, how it will be dissociated? This will be dissociated into the Al plus 3 and N minus 3, right? N minus 3. Here, whenever the lattice energy is directly proportional to the charge of the anion, right? Here the charge of the anion is minus 3. Here the charge of the anion is minus 2. Here the charge of the anion is minus 3 and the charge of the anion is minus 2. Clear? Now you may get it out. Sir, here you have said that. Now, here the lattice energy is inversely proportional to the radius of the, which one? Radius of the anion. Or here we know in the radius, if you talk the radius of N minus 3 and O minus 2, N minus 3 is having the higher radius. Then how we can say, then how we can justify this one, sir? Now how we can justify means, now if the two anions, if these two anions are having the different charge, if anions are having two different charges, then charge factors dominate. Then charge factor dominate. Right? Now here you can see both the cases what it is common. Here both the cases, charge of anion, here also charge of anion, here also charge of anion, here also charge of anion. Now if the charge of anion is same, If the charge of anion is same, then size factor dominates. Size factor dominates. Okay. This is the one very key point you have to remember. This is the one key point you have to remember. Is it clear? Is it clear, my dear friends, or still you are getting any confusion? Still you are getting any confusion? Still you are getting any confusion? No, right? Is it clear? Clear? Now this is about the right. Now this is about the right. This is about the which one? About the ionic bond. Now we are going to study about the now covalent bond. Now we are going to discuss about now covalent bond. Now we are going to discuss about the second type of the bond, that is covalent bond. My dear friend, this is summary. This is only the summary class. Only the very important points which are important for our exam. That point only I am discussing. Again, I will do this lecture properly on Saturday. Hello, Helen, Manoj. Hi. Clear? Now, in your lower classes, you have studied about that. Now, mutually sharing of the electrons leads to give the covalent bond. But here the covalent bond, it will be formed by the high electronegative element. High electronegative element and the high electronegative element. High electronegative element and the high electronegative element mutually sharing to give the covalent bond. Mutually sharing to give the which bond? Covalent bond. Example, Cl and the Cl overlaps leads to give the. My dear friend, these sessions are very much enough for your advance also. Not only for the JEE mains, it is useful for your advanced classes also. Clear? Now the covalent bond was explained and this was given by the scientist called Lewis. Now we are going to study about the Lewis concept. Okay, Lewis concept. Now what is the meaning of the Lewis concept? Now the covalent bond is formed by the sharing of electron, right? Sharing of electrons. Now how the sharing of electron? If suppose one A and one B it is there. Now A to complete its octet, it require one electron, means it will share the one electron from the A or B. Sorry, B to complete its octet, it require one electron, means it will share the one electron from the A. Then it leads to give the one covalent bond. Now the covalent bond will be represented in this manner. Why the covalent bond is representing in this manner? Because here these are sharing the electrons, but ionic bond there is no any sharing of electron. Only due to the strong attraction force between them, they are forming to give the ionic bond. Clear? Right? Now here, before going to the covalent compound, now every compound or molecule want to attain the octet electronic configuration, want to attain noble gas electronic configuration to become stable. They want to attain the noble gas electronic configuration, but the only one noble gas electronic configuration here, the NS2 NP6, we call it as a octet electronic configuration, or 8 electron species, or 8 electron species. If it is having in the shell, valency shell, if you are having the 8 electrons, that we call it as a octet, right? Now only here for the NS2, this one we call it as a duplet electronic configuration. This duplet electronic configuration will be shown by the hydrogen. Clear? Hydrogen will show the duplet electronic configuration, and if you take the fluorine will show the octet electronic configuration. Okay, Anshika, good. Now you have completed the second chapter, alcohol, phenols, ethers. Now start the carbonyl compounds. Now already we have started the carbonyl compounds, right? Now the next very most important point you are going to study here, it is the valency electrons. Valency electrons. Now what is the meaning of the valency electrons? Now the valency electrons only will participate in the bonding, in the bond formation. In the bond formation, my dear friends, only the valency electrons only will form the bonds. This is very key point. You have to be very careful with this one. To form the any compound, to form the bond, now you have to be very clear with this. Which one? It's a valency electron, right? Now the next very most key point you have to remember, very key point here, key point you have to remember. What is the key point? For D block elements, yes, complete chemistry 11th 12th by October first week I will complete all the chapters. What are the main chapters and what are the chapters we are having for the mains, I will finish it by the October first week. From October first week we will start the revision. Again the revision session will start. After the revision session we'll start the question session. First one chapter, then after that second chapter, and cumulative. In that manner it will go. 7 to 8:30 will be the first year chapters will run, and 9:30 to 11 will be the second year chapters will run. By October all the JEE main chapter will be completed. Okay, right. Now for the D block, now for the D block you have to be very careful. Now NS and N-1D electrons, NS and N-1D electrons are valency electrons. Sir, what is the NS and what is the N-D, sir? Now listen. If you take the Mn, now if you write the Mn electronic configuration, this is 1s2, 2s2, 2p6, 3s2, 3p6 and 3d5, and this is a 4s2. Now what I said, NS electrons and N-1D electrons. These are the NS electrons, right? NS2 electrons, and these are the N-1D shell D electrons. So how many we are having? NS we are having 2, N-1D we are having 5 total. Now this Mn valency electrons will be equal to 7. Mn valence electrons will be how many? 7. That's the reason Mn will form the KMnO4, we know, right? KMnO4. Now how it will be? K will readily lose the one electron. That last electron will be gained by the oxygen which is present or bonded with the Mn. Now Mn valence electrons are how many? 7, right? Now this will form the bonds in this manner. 7 bonds it will form. Now you can see how many valency electrons are there, that many bonds it will be formed, right? Clear? Right? Now the only key point you have to remember for the D block elements. Now next, covalency. Now this all also will play very important role. Covalency. Now the covalency, what is the meaning of the covalency? Means maximum number of covalent bonds, formed by elements. Karan Verma, what is what once again? May I know? Karan Verma, may I know what is the doubt you are having? My dear friend, what is the doubt you are having? Can you ask me what is the doubt you are having? Now, for the D block elements, the valency electrons will be considered as a ns electrons and the n minus 1d electrons. ns electrons and the n minus 1d electrons. Now, for the Mn, if you cross check, we are having the ns, we are containing 2 electrons. Now, nd we are having the how many? 5. Total, if you add the electrons, we got it as a 7. Total 7 electrons we got. Now in these 7 electrons, that's the reason Mn will form the 7 bonds, right? Now the next very key point we are having, that is covalency. The maximum number of covalent bonds formed by the elements is known as covalency. Now what is the meaning of the covalency? If you take the second period elements, lithium valency electrons are 1 and its covalency is also 1. Now this X indicates that electron, don't get confused. This X indicates that these are electrons. Now next one we are having the beryllium. Beryllium electrons are 2. Next one we are having the boron. Boron electrons are 3. Next one we are having the carbon. Carbon valency electrons are 4. Right. Next one we are having the nitrogen. Now the many of the students, they will get confused with the nitrogen only. Clear? Now, my dear friend, actually this is a one fast track. This is a just a summary lecture only. Now the detailed lecture I am going to take from the Saturday. Actually this is only the summary. Lecture. My dear friend, the summary lecture will be somewhat fast. I hope you will understand. Clear? And the neon, if you take, neon it is having the octet electronic configuration. From the Saturday again freshly I am going to start the chemical bonding elaborately with more number of examples. This is just only the summary. Okay. Now these are the covalency, but only the confusion we will get with the nitrogen. Nitrogen, to complete its octet, it require only 3 electrons. So its covalency should be 3. Right? Now, but nitrogen, here H2, if you take hydrogen to complete its duplet electronic configuration, it require 1 electron. So it will form the H. So its hydrogen covalency is 1. Now fluorine also, to complete its octet, it require 1 electron. Now, so the fluorine covalency is also 1. Right? Nitrogen N2. Now its valency electrons are how many? 5. Nitrogen in the N2, its valency electrons are 5. This nitrogen, to complete its octet, it requires how many? 3 electrons. Now this nitrogen, to complete its octet, it requires 3 electrons. So that's the reason nitrogen, we used to think that nitrogen covalency is 3. But my dear friends, in the JEE mains, they are repeatedly asking, and many of the students, they are choosing the answer nitrogen covalency. Means nitrogen is having the capability to form how many covalent bonds. Many of the students, they will choose the 3 and they will come and they will think that the answer is correct. But actually the covalency of the nitrogen is not the 3. Covalency of the nitrogen is 4. Now, how come the covalency of the nitrogen is 4? Only this is due to the covalent or coordinate covalent bond. Sir, how come this is a coordinate covalent bond it has came? Now, when the coordinate covalent bond, that topic when it has started, I will explain more elaboratedly. Up to now, you just remember, and you just remember that nitrogen covalency is 4. My dear friend, this is NTS favorite question. To make you confused, they will give you nitrogen can form how many covalent bonds? Nitrogen can form the 4 covalent bonds. One is a coordinate covalent bond. My dear friends, you have to be very careful with this one. Don't choose the answer is 3. Answer, if you choose the answer is 3, then it is wrong. Right? Clear? Now, next. Now, here the next we are going to see now how the molecules are having the covalent bonds. Now that was explained by the Lewis dot structure. Clear? Now rules to write or rules to draw Lewis structures. Rules to draw the which one? Lewis structures. Now only the key point, if you remember these key points, it is enough. Now what is the key point? The first key point you have to remember is central atom should be bigger in size. Central atom should be bigger in size among them. Bigger in size among them. Among them, the central atom should be bigger in size. Right? And the second one, central atom should be less electronegative. Okay, right? Clear? These are the key points. If you remember, it is enough. Next one. Now, very key point, that is hydrogen and fluorine. Hydrogen and the fluorine will never act as central atoms. Will never act as central atoms. Good. Now, Shreya, good. Now, hydrogen and the fluorine will never act as a central atom. Why? See, hydrogen to complete its octet or duplet electronic configuration, it requires only 1 electron. But to act as a central atom, it should require 2 electrons. But fluorine also to complete its octet, it requires only 1 electron. So fluorine can form only 1 bond. Now, hydrogen can also only form the 1 bond. But central atom to behave, it should form the 2 bonds. At least it should form the 2 bonds. But hydrogen and the fluorine is not having the chance to form the central atom. Why? Hydrogen to complete its duplet, it requires 1 electron. Fluorine to complete its octet, it requires 1 electron. That's the reason they will never and ever act as a central atom. Clear? Next point. Oxygen, if it is in terminal position, if it is in terminal position. Terminal position means in the compound last position. Terminal position, it forms 2 bonds. If it act as central atom. Now, depending on the nature, we have to see. Depending upon nature. Now, what is the meaning of the depending upon the nature, sir? Now, see. Oxygen, if it is acting as a terminal position. Example, I will take it as a, what is a well-known example? Well-known example for you, take it as a SO3. Now, SO3 means sulfur is a, compared to the oxygen and sulfur is a bigger size. Now, what is the first key point I said? Central atom should be bigger in size among them. Among them, central atom should be bigger in size and less electronegative. Now, we know sulfur electronegativity value is 2.5. Thank you. Something Purti, thank you. Actually, this is a somewhat the fast track lecture, my dear friends. This is somewhat the fast track lecture. Maybe I may be speed. From the Saturday onwards, more elaborately with the molecular models, with the 3D structures, I'm ready to going to explain very clearly from the Saturday. Actually, this is just recapping type. If you are not able to catch, my dear friends, from the Saturday onwards, I was explaining very clearly. Okay, you can meet over there and you can follow the lectures very clear, right? And thank you for it. Now the sulfur, it is electronegativity is 2.5, and oxygen electronegativity is 3.5. We know. Now among the sulfur and the oxygen, electronegativity of the oxygen is high. Then what I said, the less electronegativity will be having the central atom. Now the next very key point I explained you. What is the very key point? Now how many valency electrons are there? That many bonds it will be formed. Now sulfur, it is having the how many valency electrons? 6 valency electrons, right? Now each oxygen also will having the 6 valency electrons, right? Each oxygen is also having the 6 valency electrons. Each oxygen, it is having the how many valence electron? 6 valence electron, right? Now this one will form the double bond. This one will form the double bond. Now this one will form the which one? Double bond, right? Now you see, when the oxygen is at the terminal position, now it is forming the double bonds. You can see. Now if the oxygen, if it is acting as a central atom, if you best example, if you take it in the H2O, now you can see this will form the 2 single bonds, because hydrogen will never and ever will act as a central atom, right? So the only chance you may have a doubt, sir, you have said that more electronegative atom will not act as a central atom, but hydrogen is not having a chance to act as a central atom, right? So that's the reason then oxygen should have the central atom here, right? Now if the oxygen, if it is acting as a central atom, it will form the two single covalent bonds, and if it is acting as a terminal position, means instead of central atom, if it is acting as a terminal position, it will form the double bond. I hope this point is clear, right? Now we'll see some Lewis dot structures of some compounds. That is the best example for you is if you take the carbon and CCl4. Carbon, it is having the valency electrons of 4. Now each chlorine to complete its octet, it require 1 electron. Each chlorine to complete its octet, it require how many electron? 1 electron. Right? Each chlorine to complete its octet, it require 1 electron. Right? Now this chlorine, except fluorine, that's what I said, right? This 2 will not form. Only this 2 will not act as the central atom. Chlorine, fluorine will form. Joshita, chlorine will act as the central atom. Why? Due to the presence of vacant orbital. Due to presence of vacant d orbital. Due to the presence of vacant d orbital, it will accept the electron and it will act as a central atom. But fluorine case, there is no any vacant d orbital. How? 1s2, 2s2 and 2p5. Shell is filled, right? There is no any vacant d orbital. But when it comes to the chlorine case 1s2, 2s2, 2p6, 3s2, 3p5 and 3d vacant, right? Due to the presence of this vacant orbital, it can extend its octet. Chlorine can extend its octets and it can accept the electrons to the 3d. But fluorine cannot extend its octet. Only it should gain the 1 electron. Only it should gain the 1 electron to reach the octet. But there is no any empty orbital. That's the reason fluorine will not act as a central atom. But chlorine, bromine, iodine will act as a central atom. Is it clear? Joshita, is it clear? Group 17 elements can be act as a central atom, but remaining they cannot act. Fluorine cannot be act. Clear? Still you are having any doubt? Still you are having any doubt or it's okay? Right. Now you can see. Now this carbon to complete its octet, it require the 4 electrons. It will take 1 electron from the chlorine. It will take 1 electron from this chlorine, and it will take 1 electron from this chlorine, and it will take 1 electron from this chlorine. Right? Next one. This chlorine to complete its octet, it will take the 1 electron from the carbon. Now this chlorine to complete its octet, it will take the 1 electron from the carbon. This chlorine to complete its octet, it will take the 1 electron from carbon. Now this chlorine to complete its octet, it will take the 1 electron from carbon. Right? Now in this manner, it will form the carbon, it will form the 4 covalent bonds. 4 covalent bonds in this manner. To complete its octet, now it is forming the 4 covalent bonds in this manner. Right? Now, next. Now, here we are having some exceptions in the Lewis rules. Now, exceptions for Lewis rules. Now, what are the exceptions that we are having for the Lewis rules? Now, what are the exceptions for the Lewis rules? Now, the Lewis has said that now every atom should be completes it or every compound should be completes it octet. But some compounds, even though those are not completing its octet, they are stable in the nature. They are stable in the nature. That compounds we call it as a, which one? First one, hypovalent fluorine. Fluorine to complete its octet. Fluorine to complete its octet, it requires only 1 electron. So it can form only 1 bond. To act as the central atom, it should have the 2 bonds. But fluorine to complete its octet, it requires only 1 electron, means it can form only 1 bond. But to act as a central atom, central atom should provide 2 bonds. But fluorine is providing only 1 bond. How the covalent bond will be formed? See, fluorine, it is having the 7 valency electron. This fluorine to complete its octet, it requires only 1 electron. By taking the 1 electron from the hydrogen, fluorine octet is completed. This hydrogen, if it is taking 1 electron from the fluorine, mutually if it is sharing, then the hydrogen duplet electronic configuration is completed. When the compounds has reached to the noble gas electronic configuration, why again to give the another electrons and why again to take the another electrons? No chance, right? No need of it, right? No need of it only. Is it clear, Rumana? Rumana, is it clear? Or still you are having any confusion? Rumana, is it clear? Now, what are the compounds that we are having? Those are hypovalent or electron deficient compounds. Now, what is the meaning of the hypovalent or electron deficient compound means? Now, less than 8 electrons in central atom. If the central atom having less than 8 electrons, we call it as a electron deficient or hypovalent. Clear? Even though those are not having the 8 electrons, now these compounds are stable. What are that? Example, if you take the BeCl2, beryllium, it is having the central atom, it is having only the 4 electrons. How? One bond contain 2 electrons, right? Total 4 electrons only. But it is stable in the nature. Clear? Next, if you take the BF3. Now BF3, now here the boron is forming the 3 bonds. Now one bond contain 2 electrons. Now total here it is a 6 electrons. Right? Next, here even though those are not having any octet electronic configuration, those are stable. Next one. Second one we are having hypervalent. Next one we are having the hypervalent or electron rich. Electron rich. What is the meaning of the hypervalent or electron rich? Now, central atom having more than 8 electrons. More than 8 electrons, we call it as a which one? Hypervalent. Example, if you take the PCl5, phosphorus contain 5 valency electrons. Yes, good. Phosphorus contain 5 electrons. Now this is a Cl, this is a Cl, now this is a Cl, now this is a Cl, and this is a Cl. Now here total how many bonds we are having? 5 bonds. Each bond contain 2 electrons. Each bond contain how many electrons? 2 electrons. Then 5 to the phosphorus is having the more than 8 electron, 10 electron. How come? Even though it is having the more than 8 electron octet, compound are stable. Now even though it is having the less than 8 electrons, now that compounds are stable. Why it is happening like that? Now who has not explained? Now the Lewis has not explained. The Lewis has not explained. Clear? Next one. Next one we are going to see the one very interesting type of the bond, that is coordinate covalent bond. The very interesting type of the bond that we are going to study, that is a coordinate covalent bond. What is the meaning of the coordinate covalent bond? It is one special type of the bond. Special type of bond. Now it is a one special type of the bond. Electron is given by one atom. Shared between, electron was given by one atom and shared between two atoms. Electrons are given by one atom and shared between two atoms. Example, if the A is having the one lone pair, now B atom to complete its octet, now A will be donate in this manner. Now A is donor and B is a acceptor. Clear? Now to understand very clearly about this one, this bond, now the concept we have to know, that is a formal charge. My dear friends, now listen carefully. This formal charge is very, very important. Now we can expect the one question from this formal charge. Now listen. What is the meaning of the formal charge? Now the Lewis has assigned charge on atoms. Right? Now charged species are unstable, we know. Charged species are unstable. If the charged species are unstable, clear? Now example, if you take the oxygen to complete its octet, one oxygen to complete its octet, it requires 2 electrons. Right? Now this oxygen, now here the octet has been completed. But this oxygen O2, another oxygen also it has came to form the bond formation with the O2. If these electrons are completely given to this oxygen, means this oxygen 1, 2, 3. If the two oxygen completely, if this electrons has given to the oxygen number 3, then this oxygen number 2, what? Oxygen number 2 will lost its octet. So to show the bond, now the Lewis has showed the bond in this manner, and this type of the bond we call it as a which one? Covalent bond. So what does it mean? This charge on this oxygen is neutral, and charge of this oxygen is +1, and charge of oxygen is negative. Why? This oxygen number 2 is donating the electron. Oxygen number 3 is accepting the electron. So these are the formal charges. These are the formal charges on the oxygen number 2, oxygen number 1 and 2. So, but how, sir, how we get to know this oxygen number 1 is having 0, 2 and 3? For that one, he has given the one formula. That formula we call it as a formal charge. Formal charge is equal to number of valency electrons minus number of bond pairs minus 2 into number of lone pairs. If you remember this formula, you can calculate any atoms or any given compounds. Which one? Any given compounds, you can calculate the formal charge. Right? Now we'll calculate the formal charge on the each oxygen. Oxygen number 1, oxygen number 2, oxygen number 3. Right? Here the oxygen number 1 is having the 2 lone pair. Now oxygen number 1 is having the only 1 lone pair. Oxygen number 3 is having the only 3 lone pair. Sir, how come the oxygen number 2 is having the 2 lone pair, right? So then how you are saying it as a 1 lone pair? Now my dear friend, you can see this oxygen to complete its octet, it required 2 electrons. Now this oxygen to complete its octet, already it has completed its octet. Now this oxygen to complete its octet and oxygen number 3 also to complete its octet. Now this electron should be shared in the form of the coordinate covalent bond. Now what is the meaning of the coordinate covalent bond? Already I said. You can see. Now it is a one special type of the bond given by one atom and shared between two atoms. Means, what does it mean? These 2 electrons are not on the oxygen number 2, not on oxygen number 3. It is in between these two. In between these two, so that octet of the oxygen number 2 and octet of the oxygen number 3 will be completed. Sharing, they are sharing these electrons between the oxygen number 2 and the oxygen number 3. So that both the oxygens octet will be completed. Right? Now, if you calculate oxygen number 1 formal charge on oxygen number 1, if you calculate. Now, first formula, number of valence electron. Oxygen will contain valence electron 6. Right? Number of bond pairs. How many bonds it has formed? 2. Right? And how many lone pair of electrons on the oxygen number 1? 2. So that is 2 into 2. Right? Then it will give the 6 minus 2 minus 4. Right? Clear? Now 6 minus 6, it will give the 0. So the formal charge on this oxygen, we got it as 0. Now if you calculate the formal charge on oxygen number 2, then how to calculate? Oxygen valency 6. Now here the bond pair of electrons are 3 and number of lone pair of electrons are 1. Right? It will give you the 6 minus 3 minus 2. It will give you the plus 1. Now formal charge on this oxygen is plus 1. Next one, formal charge on the oxygen number 3, if you calculate 6 and the number of bond pair of electrons are 1 and the number of lone pairs are how many? 3, right? 3. Total it will give you the minus 1. How come? 6 minus 1 and minus 6. Total minus 7 and plus 6. Minus 1, right? So this is in this manner you can calculate the formal charge on the each oxygen. Right? Is it clear? I hope it is clear for you. Now I will give you one compound. Can anyone find the answer? Can anyone find the answer for the given compound formal charge? Now I will give you the one formal charge for you and I will ask you to find the, okay? Alright, wait. Now I will give one formal charge and one compound, and you have to say me the formal charge on the given compounds. Okay. Right. Now, what is the formal charge on the carbon? What is the formal charge on the carbon? And what is the formal charge on the oxygen? What is the formal charge on the carbon and what is the formal charge on the oxygen? What is the formal charge on the carbon and what is the formal charge on the oxygen? Can anyone, what is the formal charge on the oxygen and what is the formal charge on the carbon? Now, what is the formal charge on the oxygen and what is the formal charge of the? What other formulas? David, may I know what is the other, what is the doubt you are having? What is the other formula? Now, what is the formal charge on the carbon and what is the formal charge on the oxygen? If you know the, try to say me. If you don't know, you can give me the question mark. I will write it to explain. Next one, what is the formal charge on the carbonate ion? Now, what is the formal charge on the this carbonate ion? What is the formal charge on the carbonate ion? What is the formal charge on the oxygen number 1, oxygen number 2 and oxygen number 3? Now Yashwant is saying 1 and 3. How come 1 and 3, Amma? How come 1 and 3? How come 1 and 3? Minus 1. Carbon is minus 1. Now you see, actually, how this bond will be formed in the carbonate ion, how the coordinate covalent bond and how to calculate the formal charge. This carbon having the 4 valency electrons. Okay. Devansh, good evening, good evening. Carbon contain 4 valency electrons, right? Now this carbon, when it is contain the 4 valency electrons, now oxygen, it contains 6 valency electrons, right? Oxygen contain 6 valency electron. When the oxygen contain the 6 valency electron, now this octet complete. To complete the octet, how many electron it require? Clear? Now to complete this octet, this oxygen it require 2 electrons. Now oxygen octet has been completed, but carbon octet has not completed. To make the carbon octet also to complete, oxygen what it will do, it will donate these electrons in the form of this oxygen lone pair of electron will be donated to this carbon in the form of the coordinate covalent bond. In the form of coordinate covalent bond. By that you get to know that now if it is oxygen is donating the electrons to the coordinate covalent bond in the form of carbon, oxygen will get the positive charge and carbon will get the -1 charge. Directly you can calculate. But if you want to calculate with the formula, now we'll see with the formula how to calculate. Here carbon it contain how many valence electrons? Carbon contain 4. How many bonds it has formed? Carbon 3. Right? You can see 1, 2, 3. And how many valence electron it is? Sir, how many lone pair it is having? Carbon 1. Right? It will become 4 minus 5. It is -1, right? We got the -1. Oxygen, if you calculate, oxygen valence electrons are 6. Now, how many bonds that oxygen has formed? 3. And lone pair of electrons are 2. Only 1. Because this lone pair of electron has given to the bond formation. Right? 2 into 1. Then how much you will get? You will get it as a +1. You will get the +1. Right? Now, in this manner, you can calculate. Now, can anyone say me what is the formal charge on the oxygen number 1, oxygen number 3 and oxygen number 2? Now you have to say me. What are the formal charges we are having on the oxygen number 1, oxygen number 2 and oxygen number 3? Can anyone say me what is the formal charge on the oxygen number 1, oxygen number 2 and oxygen number 3? What are the formal charges that we are having on the oxygen number 1, oxygen number 2, oxygen number 3? Can anyone say me the answer? What are the formal charges that we are having on the oxygen number 1, oxygen number 2, oxygen number 3? Oxygen 1, oxygen 1 carbon minus 1. Okay, good. Next, O1 plus 1. No, O1 is minus 1. See, formal charge on the oxygen 1, formal charge on the oxygen 1, formal charge on the oxygen 1 to calculate. Now, one oxygen contain, here only single bond you are seeing, right? This oxygen, when it is forming the single bond means it is having the 3 lone pair of electron. It is having the 3 lone pair of electron. Oxygen 1, it is having the 3 lone pair of electron. Now, first valence electrons on the oxygens are 6. Now, number of bond pair of electrons are 1 and 2 into 3 valency electrons, sir, 3 lone pairs, then it will give you the 6 minus 1 and it is 6 minus 7 and plus 6 it will give you the minus 1. So, oxygen number 1 is having the formal charge minus 1, oxygen number 2 it is having the formal charge 0 and calculate the semi and oxygen number 3. Oxygen number 3 it is having the minus 1. See 6 number of bond pair of electrons are 2. You can see these are number of bond pair of electrons are 2 and the number of lone pairs are 2 into 2. Now minus 2 and it is minus 4 and minus 2. Minus 6 is equal to 0. No, there is no any test tomorrow. My dear friend, there is only the question session I will conduct at the 7 o'clock, 7 to 9 because tomorrow we have to cover the 3 chapters. 3 chapters complete questions we have to cover. Atomic structure, classification of periodic table and as well as which one chemical bonding. So 3 chapters questions we have to cover, right? So 7 o'clock to the 9 o'clock I will conduct the question session for our Saturday's exam. Okay. Now next one we are having the 6 and bond pair of electrons are 1 and the number of lone pair of electrons are 3. Then again it will give you the minus 1. Again it will give you the minus 1. Right. So 1 minus 1, 0 and minus 1 is a formal charge for the given questions. Clear? Now I hope it is clear for you. I hope it is clear for everyone. Or still you are having any confusion? Still you are having any confusion? Kindly let me know so that I am ready to explain. Now, if you are having any confusion, kindly let me know. I am ready to explain. Is it clear, everyone? Is it clear, everyone? Right. Okay, fine. Now, my dear friends, now what I will do? Okay, now it's already the time is 8:30. Should I extend the class or should I stop it here? Should I extend? Better I will stop the class here and tomorrow we'll see the question session. Question sessions will be based on the question session will be based on atomic structure, classification of periodic table and the chemical bond. Okay, almost 45 to 50 questions I will try to bring. Be prepared for the atomic structure, classification of periodic table and the chemical bonding up to percentage S character. Okay, my dear friends, up to the percentage S character, be prepared. Right? Any, my dear friends, anyone, if you are having any concerns, you can ask me. Or should I end the live? Should I end the live? Okay, fine. Tomorrow, my dear friends, be prepared for the Saturday's exam. That tomorrow we are going to take the live session from the 3 chapters. Now, if you know, right, be prepared. Now, I'm going to end the live. Should I end the live? Still, you are having any concerns or any doubts or anything you want to ask, my dear friends? Should I end the live? Okay, Amma. Fine, fine. Okay, thank you. Bye, bye. Okay, bye. Good night. Good night, everyone. Good night. Good night. Bye, Prashant. Bye. Bye, Subhana. Bye, Amit Dubey. Bye, Akshara. Bye, Yashwant. Bye, Jaushita. Right, right, right.